I have about 5 minutes to talk, to be the transition between the curriculum and technology, so it's fitting that I'm from Carnegie Mellon. The Open Learning Initiative is a project that was originally funded by the William and Flora Hewlett Foundation, and since has been funded also by the Lumina Foundation, by the Gates Foundation, and by the Spencer Foundation, and various NSF projects. And what we're really focused on is continuous improvement in teaching and learning. And the Open Learning Initiative started off as an open educational resources project. The original goal of the initiative was to create web-based learning environments that were open and freely available to everyone, so that anybody out there who didn't have the privilege of attending an institution, but by gum, just wants to learn statistics, would have, it's a normal urge, would have a reasonable chance of going onto our site and learning statistics, achieving the same learning outcomes as the student who was sitting in the comparable course at Carnegie. So from the very beginning, it's been very outcomes focused. So in order to create such environments, we realized that we couldn't just take the faculty that are teaching statistics and say, make the environment. That to create those kinds of learning environments actually requires a combination of expertise. So we brought together learning scientists, cognitive psychologists, the faculty content experts, human-computer interaction experts, and software engineers, and put them together into development teams faced with the challenge of how do you create a learning environment that supports an independent learner to achieve given learning outcomes. And so in order to do that, I'm going to just give you a couple little examples of how that gets expressed. One of them is that we know from the learning sciences that goal-directed practice and targeted feedback when you're trying to achieve an outcome really enhance the learning experience. So I'll just give you a little example of how that gets expressed in the course. This is just a small example out of a course. This is in our engineering statics course. So in this particular activity, the student is attempting to sum force vectors. And so they're given this problem. Here are the 3 vectors. Find the magnitude of the sum and the direction of the sum. So they can just go ahead and type in the answer. If it'll say, no, you didn't get that quite right, they can ask for a hint, and the hint can say, you know, if you need some extra help, do you remember the first step in how to solve this problem? And if you don't, we'll give you the first step. Remember, it's to resolve them into its component parts. And so then they go through and they can get hints and feedback at each subtask as well. So the student works through, and you can see the hints are targeted to the particular question that they're trying to solve, where they finally get the bottom-out hint, so they can answer it and keep moving. So by the time they get to the end, they've finished the whole problem, they've answered the question, but it says, great that you can do this, but you should really be able to do this without all that scaffolding and support. So it'll give them another problem that'll, and they have essentially unlimited 24/7 support in developing that fluency. So originally, I'm going to skip the next example just because I want to get to the real point. So what you don't see that's happening, so you can see how that feedback to the students supports their learning. What you don't see what's happening is as students are working through all of our environments, we're collecting interaction level data on what they're doing and how they're performing. And we're using that data to drive very important feedback loops. One of them is to the learner so that they can get feedback and refine their performance just in time while they're learning. The other one is to the instructor. So if you have a whole class of students that you are working with, instead of assigning them to work in chapter 10 of the textbook and then not knowing until the midterm what they're getting and what they're struggling with, instead, what we can do is this. Instead of assigning chapter 10, you assign module 3 in the OLI course. And you tell your students, here we are meeting Mondays and Wednesdays. So on Wednesday, I say, read module 3, work through module 3 by 10 o'clock Sunday night before we meet on Monday. So the student does that, responds to all the exercises, we're collecting all this data. Sunday night at 10 o'clock, I bring up my instructor feedback reports, and I see where are my students struggling, what are they getting? And then I plan my class to what they're needing and not cover all the stuff that they're getting. Or if they're getting everything, I can spend that time to really engage in that enriched conversation that they can take advantage of my expertise. What we found as we developed these environments that this was really the killer app, if you will. The most powerful thing about web-based learning environments, I would posit, is all that great stuff we know we can do with them. But one of the real powerful things is we can embed assessment into every instructional activity. And we can use that ongoing data that we can collect from those assessments to drive very powerful feedback loops. One of them is to the student, which I demonstrated. One of them is to the instructor. The other two that we use is one of them is to the course designers. So as I said, we have these teams that are developing these courses, but every semester we're collecting all this data about what's working and not working so that we can use that data to make another version to better support students. And in this way, we can capture all this innovation people are doing. We can capture what's working, what's not working, and use our energy to build on things instead of recreating failures or recreating success over and over and over again. And the fourth loop, which is to the science of learning, the sister project to my project is the Pittsburgh Science of Learning Center, which is an NSF-funded learning science research center. And the goal of the Pittsburgh Science of Learning Center is to understand and write learning theory. So they use our environments as the ideal lab because they can introduce experimental conditions, so you get tightly controlled research, but you get it in an authentic learning experience. Just a kind of an example of the kind of data I'm talking about. This is on, I didn't show you the stoichiometry class, but this is a learning curve. And so the y-axis is what we call the assistance score. That's the amount of support and help and feedback a student needed in order to demonstrate knowledge on a particular knowledge component. The x-axis is the number of opportunities in a variety of different problems that they had to demonstrate competence. And this is a good learning curve. This means over time, the student's needing less support, and so learning is happening. But we get these all kinds of different learning curves that tell us what to do in terms of both improving the environment and improving the student experience. We apply learning science research and scientific method to open course development, the implementation, and the continuous evaluation. The environments are collaboratively developed by teams, the only way you can really do it, and these feedback loops for continuous improvement are key. And I will end with, it's my favorite quote from Herb Simon, who was a Nobel laureate at Carnegie Mellon, and he said this almost 20 years ago, improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity. And I posit that that should be a guiding principle for us. We need to get teaching out of locked behind individual classrooms and out and treat it as a community-based research activity. That's it.